this video, I'm going to do an example of graphing a system of quadratic inequalities. Now, anytime we're graphing a system of quadratic inequalities, we're really going to shade the region that contains the points that are solutions to both equations. So, once again, our solutions are going to be points, and they're going to be points within a region that is shared. Now, to be able to shade in that region, we first need to graph both equations. So I'm going to start by graphing equation number 1. And I can actually quickly graph equation 1 by using transformations. The plus 3 on the outside is going to move the graph up 3. So I can put the graph starting at 3. And then the A is a -1. And if you recall, we can always think of our A as kind of like our slope to find the next 2 points. So that's really -1/1. So in this case, when I go over 1, I go down 1. And then when I go over 1 the other direction, I go down 1. So this first graph is going to look like this. Now, one thing to note here as I'm graphing this quadratic equation is you'll notice I've put dashed lines. Recall, any time that you have a less than sign and it doesn't have an equal to sign underneath it, you'll need to graph that line with a dashed line. And the dashed line just tells you that the points that fall on the dashed line are not included in the solutions. Now that we have one of the equations graphed, we need to go ahead and graph the second equation. So the first thing to notice is that this second equation is in standard form, so I'm going to have to graph it using the standard form method, which is taking the opposite of b over 2a, which will give me the x-coordinate of the vertex, and then I need to plug that value back in. So plug back in the x to get the y value. So if I go ahead and do that quickly here, if I take the opposite of b, well, that's just -2. And then if I put that over 2 times a, well, right now my a is 1. And if I multiply that by 2, I'll get -2/2, which really just equals -1. So right now the x-coordinate of my vertex is going to be the -1 value. Now, continuing on this idea, I want to plug the x back in to find the y. So I can just take -1 and plug it back into my equation. So for instance, if I take -1 squared plus 2 times the -1 and then -3, and then I can solve this and it'll give me the y value. So -1 squared is 1. 2 times the -1 is really just -2. -3, I'll end up with -4. So my vertex is at -1, -4. Now, if I go ahead and graph that, well, if I go -1 and then down 2, 3, 4, my vertex point will be at this point. And then once again, I look at my a. My a is 1/1. So I can go over 1, up 1, over 1, up 1. And then once again, I look at my sign and I see that it does have an equal to sign. So this time I'll use a solid line. And just to recall that the solid line means that there are solutions. So any point on this line is a solution. And then once again, my solutions are the points that fall within the region that is shared. So I just kind of need to test a point and see if it works. So for instance, if I test the point 0, 0, I want to test it on both equations. So if I plug 0, 0 into the first equation, well, I'll get 0 is less than +3, and that's a true statement. So for this first function, I'll see that the solutions are underneath it. And then if I plug 0 in for my second equation, well, I'll get 0 is greater than or equal to -3, which is also a true statement. So all my solutions must be above the second line. So I can shade in the region above this second line. And you'll notice that I'm shading in the region that they have in common, and it's the inside, so my solutions will be on the inside of those two functions. Now, one other way you can kind of find the region that you need to shade in is this first line that I graphed was a dashed line going down. Notice it doesn't have an equals to sign, and it's all the y values that are less than the equation. So it's going to be all the y values that are lower. So I'm shading in the lower half. And then if I look at this equation, it's going to be all the y values greater than the equation, so it should be all the y values above. And then once again, the solutions are the points in the region that are shared by the two equations. So it's going to be below the first equation, the dashed line, and then above the big line, and only this region holds those two qualities. So this is where my solutions lie.